Today we're going to talk about combinations. Combinations are similar to our permutations that we looked at in the last section, but there is one big difference that we're going to spend kind of the first couple of examples talking through. So in the last section we were looking at permutations. When we're dealing with permutations, the order of the object matters. So when we're thinking about permutations, we're thinking that the order of the objects matters. When we're dealing with combinations, right, the order is unimportant for our final outcome. So the big difference is for permutations, order matters. For combinations, the order is not important. So in permutations, the letter combinations ABC and CBA are different because when we're thinking about permutations, we're thinking about order mattering. So whether or not we're in alphabetical order or reverse alphabetical order, we have differences. Right? However, if we're thinking about a combination, well, they're the same. ABC, CBA, or BAC, right? Any way we arrange those three letters, as long as it's those three particular letters that have been chosen, the order doesn't matter. So in this section, again, we're focusing on our combinations. So our order or our regard to their arrangement does not matter. Right, so example 1 here, we're going to compare permutations and combinations. So determine whether the situation represents a permutation or combination problem. All right, so a group of 5 friends. All right, Arlene, Inez, Judy, Dan, and Eunice are forming a club. The group will elect a president and a treasurer. And how many different ways can a president and treasurer be elected? So this particular example would be one of a permutation. It is a permutation because order or arrangement matters. So we're going to say it's a permutation because the arrangement matters. Because the position of president and treasurer are different. So if order matters or if there is a difference in the arrangement, as there is in this case, it is an example of a permutation. All right, for B, of the 5 individuals named, 2 will be attending a meeting together. And how many different ways can they do so? Well, this particular example would be one of a combination. Okay? And this is a combination because the order of the 2 people selected does not matter. Right? All that matters is who gets chosen in the end. The order doesn't matter. We're not talking about different positions. We're not talking about different arrangements. We're just talking about a combination of 2 different people. So as we're going through these next couple of problems, what we're thinking about and what we want to keep in the back of our mind is whether or not order or arrangement or different positions matter. Okay. Our compilation formula is listed down here at the bottom. The number of combinations when our objects are selected is found by our combination formula. It looks very similar to our permutation formula. The difference is we're actually dividing by an extra factorial in our divisor. So we still have the number of different objects that are looking at. That's going to be our top number, and we're going to use that factorial. And then we're going to subtract our 2, so how many objects are being selected and how many objects we had to originally consider, find the difference between those 2. And then we're also going to divide it by our r factorial, so it's slightly different than our permutation formula. Right, so in example 2, right, an exam consists of 6 questions. Any 4 may be selected for answering. And how many ways can the 6 selections be made? Right, so looking at this using our notation, we have 6 questions and we are selecting 4. Order doesn't matter, right? So it doesn't matter which order we pick the questions that we would answer on the test. All that matters is that we're choosing 4 out of 6. Right, so our n factorial is our 6 factorial because our 6 factorial is our number of objects that we're being chosen from. N minus r factorial is going to be 6 minus 4 factorial. And then our r, the number of objects that are being chosen, is our 4 factorial. So if we do our subtraction, we're taking 6 factorial divided by 2 factorial times 4 factorial. All right, so if we were to write these out, our 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Our 6 minus 4 factorial is our 2 factorial, so that's 2 times 1. And then our 4 factorial is 4 times 3 times 2 times 1. All right, then looking at what we can cancel out, we can cancel out 4 and everything below it. Right, and then I'm going to go ahead and divide and cancel with this 6 and this 2. 2 goes into 2 twice, so that's going to leave us with a 1. 2 goes into 6 3 times, so that leaves us with a 3. And we multiply what we have left. Well, we have 3 times 5 over a bunch of 1s, so really just 3 times 5. 3 times 5 gives us 15 combinations. As we mentioned in the previous section, you can definitely use your calculator to find these. Whether you're using a scientific calculator or a graphing calculator. All of these different things for section 11.7 and 11.8 are found in that probability menu. Right? So on your scientific calculator, there's a little button that says PRB for your probability, and you can choose factorials, you can choose permutations or combinations, and then on your graphing calculator, we're using one of the math functions. But again, you can make your choice of your different types of selections for either a factorial, a permutation, or a combination. Okay, so for example 3, we're going to look at another combination problem. Jan has 10 different cut flowers from which she will choose 6 in a floral arrangement. How many different ways can she do so? Okay, so we have a total of 10 items, right, and we are choosing 6 for our combination. So we're going to take 10 factorial, subtract these, 10 minus 6 factorial, right, and then we take the number of objects that we're choosing, so that's our 6 factorial. Right. And then again, I'm going to go ahead and work through this one by hand, but feel free to use a calculator if you choose. Right. So 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, 10 minus 6 factorial is 4 factorial. So 4 times 3 times 2 times 1. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. All right, then to cancel these out, right, our 6 factorial cancels in both our numerator and denominator. Then looking at what else we have, 4 and 2. 4 times 2 gives us 8. So I'm going to cancel these out when I cancel out my 8 up top. Okay, and the last thing I'm going to cancel, 9 divided by 3 is going to give us 3. Okay, and I'm going to multiply what I have left. So I'm going to take 10 times 3 times 7, which gives us a total of 210 combinations. Again, feel free to use your calculator to assist. Feel free to use your factorial button, your combination button, or do canceling and kind of work them out by hand. It just kind of depends on how large of a problem you have that you're working through. All right, so our last example for this section then, we're looking at dinner combinations. So at a Chinese restaurant, dinner for 8 people consists of 3 items from column A, 4 items from column B, and 3 items from column C. If columns A, B, and C have 5, 7, and 6 items respectively, how many different dinner combinations are possible? So what we're going to have here is we're going to use our combinations, but we're also going to think back to our counting principle. Our counting principle means we need to multiply our different numbers together. So our total number of choices is going to be the choices that we have from column A times what we have from column B times what we have from column C. All right, so for column A, right, column A, we're choosing 3 items, and if we look at the way this is written, column A goes with 5. So our first combination that we're going to do is going to be 5C3. So we're choosing 3 out of the 5. Right, column B, we're selecting 4 items from column B out of 7 total. So we're going to take this times 7C4. And then for column C, we're selecting 3 items out of 6. So 6C3. Okay. Now, partially for comparison sake, I'm not going to work through every single one of these combinations by hand using what we did in example 2 and example 3. We're just going to use our calculator to generate these different values. So if we type 5C3 into our calculator, right, that's going to give us 10 combinations for that first column. 7C4 is going to give us 35 combinations for that second column. And then 6C3 is going to give us 20 combinations for that last column. Then if we multiply these all together, we get 7,000 combinations. If you look at the notes that are posted online, this problem is worked through step by step, showing all of the different cancellations. Again, as you're working through these problems in the homework on the mini quiz, feel free to use your calculator to work through some of the arithmetic and or work it out using fractions and cancellation as I did in the previous 2 examples.